What if everything we know about life in the universe is just a small part of a much bigger picture? We are used to thinking that Earth is unique, the only planet where life has emerged. But the more we look into space, the more strange signals, anomalies, and discoveries appear that don't fit into our usual picture of the world. Traces of gases that can only be produced by living organisms. Satellites with subsurface oceans. Planets where the conditions are unexpectedly closer to Earth's than we anticipated. The main question is becoming increasingly troubling and interesting. Are we really alone in the universe, or do we just not know how to look properly yet?
We are incredibly lucky that Earth is located near a stable star and has the necessary conditions that allow people to live comfortably on it. But is it really so bad on other planets? What if life exists not only on Earth? Are there places that are much more suitable for life? For example, recently, traces of extraterrestrial life were discovered on Saturn's moon, Enceladus. In its geysers, scientists found methane, which most likely confirms the presence of life on Enceladus. Or maybe it's just geochemical or thermochemical processes. But there's so much methane in Enceladus's geysers that such an amount can't be explained by non-biological processes. Halo. Scientists conducted a series of studies, but they still couldn't explain where so much methane in the geysers on Saturn's moon comes from, especially since its reserves are constantly being replenished and escaping into space. However, everything falls into place if we assume the presence of microbes there, similar to those found in hydrothermal vents on Earth. Scientists believe that enough hydrogen is produced on Enceladus to support such microbes, and the temperature remains comfortable. Is there life on Enceladus? No one is ready to say this with 100% certainty. They say that complex deep-sea missions are needed, which are expected in the next few decades. Something similar happened with Venus. Phosphine was found in the clouds of this planet, a gas that is produced only industrially or by microbes living in an oxygen-free environment. When scientists first got hints of phosphine in Venus's spectrum, they were so shocked that they couldn't believe their luck for a long time. How can the presence of this gas be explained? There were suspicions that phosphine could have entered the atmosphere as a result of non-biological processes. But it turned out that all non-biological sources produce at most 1/10,000th of the amount of phosphine that was detected by the telescopes. Phosphine, or more precisely phosphorus hydride, is a poisonous gas that has no color and is very rarely found in nature. As a rule, it is released during chemical reactions in manufacturing, when lightning strikes, or as a result of volcanic activity, but not in the large quantities in which it was found on Venus. How did it end up there? Most likely, as a result of the activity of bacteria that live in an oxygen-free environment. This version seems the most likely to astronomers. However, they do not rule out that they might have missed something, and perhaps there is another explanation for where so much phosphine on Venus came from. At the same time, research fellow of the Space Research Institute of the Russian Academy of Sciences, Natan Eisman, is convinced that Venus is the most likely place to discover life. For this purpose, the Venera D project has already been approved. But why are such high hopes placed on Venus in particular? According to Eisman, it's because Earth and Venus are very similar. They have similar masses and sizes. But will the search for life on Venus be successful? Most likely no. After all, even in the atmosphere where phosphine was detected, the air is extremely dry and acidic, with almost no water. In addition, Venus is almost 1.5 times closer to the Sun than our planet, and its surface is too hot for any forms of life to exist there. The average temperature there is about 460 degrees Celsius, conditions under which even lead melts. This means that if astronauts travel to Venus in the future, they would first dissolve in sulfuric acid and then be poisoned by toxic phosphine. If there are any creatures living there, we won't find out about them anytime soon. However, Scientists are confident that there was a time when Venus had a much milder climate, and its surface was most likely covered by oceans where life could have originated. However, the strong greenhouse effect dried up the oceans, and now only microorganisms might be able to continue existing there. What about other planets? Maybe somewhere there are more suitable conditions for life? In 2020, British scientists discovered that Jupiter's atmosphere is more humid than Venus's. Of course, the harsh conditions on the planet's surface leave no chance for even the most resilient forms of life to exist there. But recent scientific discoveries leave the question of the possibility of life on this planet open. The fact is that sulfur dioxide was found in Jupiter's clouds, and the droplets contain a fairly large amount of water. If we assume that there are nutrients there, then microbial life could very well exist in Jupiter's clouds. And maybe not just microbial life, at least on Jupiter's moon Europa. It's suspected that beneath the thick layer of ice on this small moon, alien life might be hiding. Data from telescopes and spacecraft give reason to believe that Europa may be hiding a global ocean from us, which the solar system prevents from freezing. Who else could live there besides microbes? Monica Grady, the rector of the University of Liverpool, tends to believe that Europa may boast more advanced life than Mars. Thanks to the warm subsurface ocean, the living conditions on Jupiter's moon are more comfortable and may provide better chances for survival. In addition, organic substances rise from the depths of the moon, which can serve as food. If this is really the case, future colonists may well encounter much more advanced forms of life than previously thought. There is an opinion that the intelligence of some inhabitants of Europa may correspond, for example, to the level of a squid or an octopus. What if there are mermaids or amphibious people living in Europa's ocean, and we just don't know about it? They feed on the creatures that live there and live in their underwater homes? There are no answers to these questions yet, but experts tend to believe that life forms similar to humans are unlikely to appear in the vicinity of Jupiter. The reason for this is the lack of light in the depths of the ocean and the immense pressure from the thick ice. Inside the dwarf planet Ceres, there is also a real ocean. Scientists came to this conclusion after studying the eruptions of the cryovolcano Qatar, located on Ceres. Cryovolcanoes are a specific type of volcano found on planets and celestial bodies that are characterized by extremely low temperatures. Instead of hot lava, they erupt a mixture of water, ammonia, and methane. According to scientists, cryovolcanoes indicate the presence of water inside the planet Ceres. Deposits of sodium carbonate have also been discovered on the surface of the planet. Paul Schenck from the Lunar and Planetary Institute believes that the similarity of certain processes on Mars, Earth, and Ceres may indicate favorable conditions for the emergence of microorganisms. In his opinion, life simply had to emerge on water-rich Mars and Earth. After studying the cartography of this dwarf planet, Paul Schenck discovered similar deposits in the area of the Akatar crater. Some elements are the most common in the universe. These are hydrogen, carbon, oxygen, nitrogen, silicon, and iron. They are essential for the existence of organic life. In particular, a human needs water to drink, air to breathe, and a planet with a surface to move around on. If all these components were once able to come together on Earth and start the processes necessary for the development of intelligent life, then why can't this also happen on one of the hundreds of billions of exoplanets that exist just in our galaxy? According to the laws of statistics, life simply had to originate not only on Earth. The only question is whether we will discover it, and if we do, what actions will follow after that? Over the past 30 years, astronomers have discovered more than 4,000 exoplanets, planets that are located outside the solar system. Most of them orbit their own stars. Many of the discovered exoplanets contain the same elements as the planets of the solar system. There are only minor differences. Some are dominated by water and ice, others by iron and carbon. However, there is not a single planet that is similar to Earth or other bodies in the solar system. However, there are also so-called terrestrial planets. For example, TRAPPIST, 1D like Earth, is the third planet from its star, and its soil composition may be similar to Earth's. This object is also located in the habitable zone, an area where the amount of heat from the star is sufficient for liquid water to exist on the surface. Now let's take a look at TRAPPIST-1e, whose mass is 60% that of Earth. Remarkably, a year here lasts only 6.1 days. An interesting fact is that the density of this planet is several times greater than that of Earth. It's all due to a denser iron core, which may be the reason why the planet's atmosphere is thinner. And this means that the presence of oceans on the planet is in question. However, TRAPPIST-1e is most similar to Earth in size and in the amount of energy it receives from its star. Could intelligent life exist here? So far, we don't have enough computing power to study these planets in more detail. However, the astrophysicist believes that in the search for life in the universe, we have a better chance of finding bacteria than an intelligent civilization or Star Wars. For such a civilization to arise, it takes time as well as stable basic physical conditions. Earth had those advantages and more besides. For example, the moon gave us an optimal climate, and the gas giant Jupiter attracts almost all the asteroids flying into the solar system. Without Jupiter, Earth would have much more frequently faced catastrophes, like the one that wiped out the dinosaurs 65 million years ago. So for now, the facts only suggest that if there are any extraterrestrial inhabitants out there, they are single-celled, at least in the solar system. Or maybe we simply didn't overlap with intelligent beings in time and space. The James Webb Telescope has already provided us with amazing photos of various cosmic objects more than once. Today we'll talk about its image of Neptune, the farthest planet in our solar system. The image of the planet provided by the telescope is considered the most detailed since 1980. Neptune, although it's very far from us, holds many amazing secrets. The image by James Webb was taken in infrared. This means that the colors in the image do not match those in reality. For example, if you look at the images provided by Hubble or Voyager 2, you'll see a distinct dark blue color. Scientists have not yet been able to determine why Neptune has such a remarkable color. Let's get back to the image from James Webb. You have to admit it kind of reminds us of a lantern. Since our vision doesn't perceive infrared radiation, we can only see the differences between the shades on Neptune. There are noticeably brighter areas on the planet. Their appearance is due to the huge amount of ice on Neptune, which has a high reflectivity. The same bright features on the disk are clouds made of ice. They formed due to the low temperatures in the upper atmospheric layer about -220 degrees Celsius. In the images provided by Hubble and Voyager, you can also notice these icy clouds. However, with James Webb, they are seen more clearly. There is constant interaction between the clouds. On Neptune itself, the weather conditions are quite changeable, even though the planet is far from its main star, the Sun. This was recorded back in 1989 by one of the Voyagers. If we compare Neptune with Uranus, which is actually closer to the Sun, the weather on Uranus changes much less frequently. This is far from the only amazing fact about Neptune. It turns out that in the upper layers of the atmosphere, the temperature is higher than in the lower ones. The upper layer, which is located 90 kilometers above the surface, is called the thermosphere, and its temperature reaches as high as 500 degrees Celsius. We still don't know exactly why this happens. Whatever the conditions are, it's unlikely that ultraviolet radiation alone would be enough for the temperature readings in the upper part of the atmosphere to be this high. Nevertheless, this paradox remains, and it affects weather changes as well. In fact, everything here depends on temperature fluctuations. In the case of Neptune, the difference can be very large, which contributes to the formation of extremely powerful winds. Their speed reaches an incredible 600 meters per second. Based on the Earth's wind speed scale, the winds on Neptune are stronger than hurricane-force winds on Earth, which usually have speeds of about 118 kilometers per hour. We have already found out that we are dealing with a planet that has high temperatures, even despite its great distance from the Sun. In theory, if an astronaut were to land on Neptune as he descends, he would feel how rapidly everything around him becomes hotter. The regions where the gas becomes something like a liquid mantle heat up to 5,000 degrees Celsius. There is a theory that the upper layers of Neptune's mantle may be covered with liquid carbon containing some amount of diamonds. Because of their mass, they sink deeper, eventually reaching Neptune's core, where they heat up even more and then evaporate. In this way, they enter the atmospheric layer and return to the surface as diamond rain. And this process repeats many times. Just recently, literally a month ago, scientists simulated the same diamond rains under laboratory conditions. To do this, they had to heat fragments of a plastic bottle to 6,000 degrees Celsius. As a result, they obtained so-called nanodiamonds. Thus, it became certain that diamond rains do exist on Neptune. But the question of why Neptune has such high temperatures, even though the planet receives 40% less solar energy than its neighbor Uranus, still remains unanswered. An interesting point. If we compare how much energy these two planets emit, Neptune's value is twice as high as that of Uranus. Despite all this, Neptune's atmosphere heats up to unimaginable temperatures. And on the surface, due to sharp temperature fluctuations, the strongest storms and hurricanes occur. Let's also talk about Neptune's surface. Despite the fact that the planet is one of the ice giants, it has a rocky core composed of silicates, iron, and nickel. This creates another paradox. Usually, the density of planets that are located closer to their main star is higher than those that are farther away. This has been confirmed many times. For example, Venus or even Earth are smaller than the gas giants, but their density is higher. An interesting point is that among all the gas giants in our solar system, Neptune has the highest density, 1.64 grams per cubic meter, and its density is 3 times higher than Saturn's density. It would make more sense if, out of all the planets in the solar system, Neptune was less dense, lighter in mass, and colder. And again, we don't know why this happened. The rings of Neptune are also important for study. James Webb captured them for the first time in a long time. The last time they were captured by researchers was when the Voyager 2 spacecraft studied them in 1989. This image helped scientists confirm the existence of rings around Neptune. James Webb, in turn, provided us with new data about these cosmic structures. Compared to Saturn's rings, Neptune's are not as prominent. They are barely visible to the naked eye. At the same time, it's noticeable that they consist of 5 components. The rings are mainly made of ice. There is also a small amount of carbon. It is likely that in some places the rings have a reddish color. That color comes from the presence of silicates and carbon-rich materials. Unfortunately, Neptune's rings may disappear completely soon. Based on observations conducted since 1989, some of the rings have already disappeared. Researchers suggest that within 100 years, Neptune will no longer have any arcs at all. Despite this, a new ring will appear in place of the vanished one. And it's all thanks to one of Neptune's moons, Larissa. It doesn't have a perfect spherical shape, it's more like a rock. This isn't Titan or Ganymede. Larissa will eventually just break apart under Neptune's gravitational force and become its new ring. At the same time, it won't impress us with its size, since Larissa's radius is about 97 kilometers. However, it's worth noting that 13 out of Neptune's 14 moons have insignificant mass and size. Triton stands out among them all. Its mass makes up 99.5% of the total mass of all Neptune's moons. James Webb captured it as well. You can spot Triton in the upper left corner. In the image, it appears as a glowing object. The surface of Neptune's moon is covered by a layer of ice. That's why in the photo by James Webb, Triton is so bright. It's also noteworthy that Triton is only about a third smaller than the moon. Its radius is 1,353 kilometers. By the way, because of such huge planetary moons, Pluto once lost its status as a full-fledged planet and became a dwarf planet. Triton is also notable because it has an atmosphere. Only 3 moons in the solar system have one. Cryovolcanic activity has also been observed on Neptune's moon, as confirmed by images from Voyager 2. The temperature on Triton is about minus 235 degrees Celsius, making it the coldest object in the entire solar system. And most importantly, about 35% of Triton's surface is made up of liquid water. And this is despite the moon's distance from the sun. Let's get back to Neptune. In the image, you can notice a peculiar glow at the planet's north pole. It is assumed that these could be icy clouds, which are especially abundant at the North Pole. We can't find out the reasons for this phenomenon at the moment because we simply don't have the ability to observe the North Pole. The thing is, Neptune completes an orbital revolution in as many as 164 Earth years. And at the moment, the planet is positioned in such a way that it can't be properly observed from Earth. James Webb was sent to Neptune to learn more about its weather conditions. Other telescopes just didn't provide a broad picture of this. Despite the huge amount of data, Neptune still holds many secrets that will be uncovered by the next generation of scientists. Is it possible for absolute silence to exist on planet Earth? No. Surely everyone knows this, but there are specially designed chambers with powerful soundproofing. The thing is, Earth's natural environment is still filled with a multitude of sounds. But what about this in space? Is it possible for complete silence to exist in the universe? While admiring the mesmerizing eternal spinning of the planet and the brilliance of the stars, we rarely think about what it sounds like. Moreover, blockbuster creators have accustomed us to the idea that the howl of bullets fired from space blasters, epic star explosions, and interplanetary shuttle collisions are accompanied by heart-wrenching sounds. Many take this at face value, mistakenly imagining space as a rather noisy place. That's not the case, although the universe does have a voice. Let's start with a bit of theory. Sound is elastic waves propagating in a liquid, solid, or gaseous medium. In the latter case, it's air. The human ear perceives these vibrations. But in a vacuum, this is impossible. So where does the music of space, which you can often hear on NASA's website, come from? For example, this is not the noise of a deadly hurricane on Earth, but the eerie voice of a black hole. Let's reveal a simple truth. Just because there's no air in space doesn't mean there aren't waves there, like electromagnetic ones. The second point, vacuum is a kind of atmosphere, just extremely rarefied. Absolute vacuum is a myth. It doesn't exist in the universe. The apparent emptiness is filled with dust particles and hydrogen atoms. If the vacuum isn't empty, then there should be sounds in it, but for some reason, there's dead silence, and even the explosions of giant stars are completely silent. Such a fact is surprising only under Earth's conditions and for beings that have hearing organs. But this is not the only way to perceive the world around us. Remember, even on our planet, there are bats capable of detecting vibrations that are beyond our perception. The range of human hearing is from 20 Hz to 20,000 Sa. In this case, the range includes ultra-long radio waves. We can't hear them, but we are able to translate such vibrations into human language. To do this, it's enough to convert electromagnetic oscillations into radio waves and play them through headphones. Then people will discover a talkative cosmos. Everyone should experience this amazing journey because the conversations of planets, stars, and black holes are very meaningful and unlike each other. Some evoke eerie associations, others make you feel a sense of danger, and still others provoke involuntary awe. By the way, it was Voyager that first recorded the voices of space, and later NASA, inspired by the translation, released a disc with a variety of sounds from space. The Hubble channel invites viewers to experience an indescribable range of emotions while listening to the voices of space, transformed into sounds accessible to us. First, I would like to introduce the voice of the Sun, the main star that gives us the opportunity to live comfortably on our planet. Its voice is like millions of drums beating in unison, merging into a mystical, eternal, mesmerizing hum. Speaking of distant stars, the final song of the dying red giant R Sculptoris, located 1,500 light years away from us, is remarkable. Since such an end awaits our Sun in 5 billion years, the voice of a fading star is especially interesting for people on Earth. Astronomers from Atacama recorded the radio emission of R Sculptoris and created a composition from it, similar to a music box. The sound is similar to raindrops falling from a tree branch into a metal vase, or to chaotic, lazy touches on piano keys. The gradual fading of a star evokes longing, immersing you in thoughts of the eternal. The voice of Jupiter is just as impressive as the planet itself. It sounds like an alarming toll of bells. At times, the sound turns into a howl and a hum, as if the wind is blowing through empty tunnels. Sometimes the voice of the planet sounds like a distant ocean surf. After listening to it, a feeling of loneliness and being lost comes over you. The Jovian song was even mentioned in Arthur Clarke's Space Odyssey. Every celestial body has its own voice. This otherworldly howl comes from Saturn and its many rings. This nervous, calm noise, resembling the sound of the sea breathing or a distant airplane, is the voice of Neptune. The moons of the planets also call to one another. Ganymede's magnetosphere echoes with the sounds of earthly thunder. Their rumblings are clearly heard in the cosmic wasteland. If you go very far into space, you can hear what pulsars sound like. Their voices sound like machine gun fire or the blows of a giant stenographer typing on a colossal typewriter. Finally, let's demonstrate what Earth sounds like from space. Over the oceans, the sound hums, like pressing your ear to a large seashell. Over the mountains and ice caps, you can hear a noise similar to the howling wind at the summit of Everest. And above the burning lights of the continents, it's a mix of sounds, among which you can hear voices like the wailing of sirens, the chirping of birds, and the humming of wires. You can listen to the voices of space endlessly. They awaken something long forgotten, ancient, deeply hidden within us by civilization. Let yourself go, listen to the music of the universe. Well, that's a brief summary about it. We are very pleased that you are happy, that you love, and that you discover new things. The Hubble channel will be happy to help you with this. And for that, all you need to do is give this video a huge like, click the subscribe button, and wait for the next episode. And it's coming very soon. Really very soon.